Networking is integral part of any cloud application you are going to build. We will not be talking about the whole networking, but I'll give you some idea about the common concept of networking so you will feel comfortable leading these conversation or designing your application. We will be focusing on physical versus logical addressing. We'll talk about two network devices, switches and router. They are not the only two, there are more, and we will talk about some more common terminologies. Let's first understand physical versus logical addressing. If you are a mobile user, which I'm pretty sure you are, you get a mobile number. It is a 10-digit logical address which is given to you. So you talk to a service provider, like I'm using Vodafone as a service provider. So I talk to them, I need a phone number, they give me a SIM and that has a 10-digit address associated. It is assigned by the mobile service provider and the format would be in something like this. Now, I can change that and go to another service provider, or I can take same number to another service provider. But there is one more number which makes my calls possible. That is called IMEI number. It is International Mobile Equipment Identity. This is the physical address which is of 15 digit and it is assigned by the device manufacturer. The time mobile is created or manufactured, that time it is embedded into the system. It is like a fingerprint. You have a kid, you can name him or her anything, but the fingerprint is there which you cannot change. Name can be changed. Similarly, physical addresses are embedded into the system for identification and for other purposes. Same way we have our concept of physical and logical addresses. When we talk about IP addresses, we are focusing on a logical address. So you assign these server addresses which are in format of something like this, like 10.1.1.2 or something, and then it can be 128-bit also, but these are called my logical addresses, mostly assigned by a DHCP server. We'll talk about it, dynamic host configuration protocol server. It can be assigned manually, but this is a logical address which you decide what you want it to be. These addresses are assigned to network devices. Those network devices could be your network card, LAN card we call them. It could be your routers, it could be your switches, or it could be some other firewall devices or load balancer you are installing on your physical network. All of that would require IP addresses. They also have something called a MAC address, Media Access Control Address. It is a physical address and it is assigned by the device manufacturer in the format of 48 or 64-bit. That is what is embedded into the system itself. Do we need to deal with them? Answer is no, we do not need them. We mostly focus on IP addresses and through which all my communication happens. So hopefully this thing is clear. What is IP address? What is a MAC address? When we use IP addresses, so most communication when we do happens at IP addresses, but in some communications, in every communication, MAC addresses are used, but behind the scene we don't see them. Like we remember people's mobile number and call them rather than remembering their IMEI number. We cannot call them through IMEI number. So same thing applies into network also. Now you have to be aware about some more common concept. Like these are very commonly used concept. Like we talk about, hey, we do not have sufficient bandwidth and all. What is bandwidth? Consider that you have pipes of different sizes. If pipe is small size, the water inflow or outflow can be small. Same thing here. Maybe bigger pipe, maybe will have more water flow. So that is what a bandwidth is. Bandwidth controls how much water can flow, how much packets can go from it. So packets are like water. And in your house also, when you have your plumbing, that plumbing will go through different type of devices like fitting. There would be taps, there would be valve, there will be pump. These are all the network devices who control the flow of water or they divert the flow of water to a specific place. Same thing in network, we have network devices and those devices ensure that we are able to send packet to a destination of our choice. Same analogy in terms of road. So bandwidth is like number of lanes. So you have smaller 1 lane, 2 lane, 4-lane, 6-lane traffic. Obviously you can carry more vehicles on that. Network devices are component on the road like ramps, traffic signals, signs and map by which you navigate your network or navigate your path, and packets who are traveling are your vehicles on which your data is transported from one place to another place. So that hopefully clarifies some concept. Whenever it comes to networking, most of the time, or I would say almost every time, you would have heard about OSI model at the very foundational layer. OSI is a theoretical model, open system interconnection. Why it was invented? In early days when networks were created, different companies were creating their different ways of communication, and that created compatibility issue. Device of one vendor may not work with other vendor can communicate, but you cannot cross communicate, those type of thing. So to avoid all these kind of compatibility issues, the concept of OSI model is created. So they thought communication can be logically divided into these 7 layers, which are L7 to L1 or L1 to L7, or from physical to application. You decide what you want to use it for or how you want to remember it. But in every device there are in every layer there are different type of devices who would be allowed to communicate. Like my firewalls may come from L7 to L3 network layer up to application layer. My switches would operate at data link layer. Physical devices will operate at network card, and router would operate at network layer. If you want to know about OSI model, there are lot of videos available on internet which you can look into, should not be an issue. How things identified? Things are identified by the IP addresses when it comes to routers. Router know what is a IP address, and based on that they forward the traffic, whereas switches, they know MAC address, and by that they perform traffic diversion or traffic forwarding. So packets are there which have header and payload, which will be used to transfer your data. So what is a packet? Packet is the unit by which your data get transported, and within packet you would have your actual data, or we call it payload, and with that they would have additional information to get it delivered. Like you are sending someone a letter would be inside an envelope. So envelope is your header, which contains information about to whom this letter is going, from where it is coming, if it is a priority mail or not, and all other stuff. And your actual data is within the letter inside this envelope. That is your data you want to transfer. So that's what packet, header, and payload is. Now let's talk a little bit on switches. When you are building a network, the first thing you would need to set up in your physical infrastructure would be switches probably. So network switch forward data between connected devices. Initial days, let's say if we had 2 devices to communicate, so between these 2 we could have created a cable connection, and through that things will work out. But what if I have to add a third device? So I can still have a cable coming from here to here, here to here, and one more, and that will be complicating the situation when I keep on adding devices. So rather than that, we said, hey, can we find out a better option available? Answer is yes. Rather than having these cables communicating individually, why don't we create a switch, which is a central device, and through this central device we are able to perform the transferring of the data. So that is what is referred as a switch. How a switch works, we will talk about that, but you will find managed versus unmanaged switches. Managed switches, where you have a software level control on the switches, you can control various aspects of how the switching happen. Unmanaged switching is like a dumb switch who just forward information based on whatever data comes in or based on the information it received, but it has not a configurable option available with it. That is referred as unmanaged switches. Most of the time you may have heard about companies like Cisco, you may have heard about Juniper, which are very commonly used hardware at the data center layers, and then we may have other vendors also who are providing you switches. Switches can be as small as this. Maybe within your closet you have a 4-port, 8-port switch. We call them ports, 4-port, 8-port for home usage, and if it is enterprise, these all are the options, or these are all the ports where I would be connecting cable and through which I would be able to send my traffic inside out. How a switch switches, let's talk about that in a minute. So switch works with a MAC address. So every switch having a memory which is called CAM table, content addressable memory. As soon as you power on your device, let's say this is my device A, B, C, D, as soon as they power on, they would have your network card, and that network card would send some signal out, and that will have the MAC address of the network card. So switch received a packet on first number port. Now it knows, oh, there is a device whose number is 2231. So it learned about it. There is a packet coming from 9945 on port 2. So it would maintain a table. So it knows who is all connected to me and to whom I can transfer traffic. So whenever request comes in, it checks who is the destination, which port the destination is, and then it forwards the traffic into that port. Now, if this device device is currently shut down, there would be no entry in switch for that device. As you could see, D has no entry on port 4 because let's say it is shut down. As soon as you would start it, it would have its entry, and as soon as it is shut down, after a while it would be removed from the table, and that's how switch performs switching by looking into the MAC addresses of the devices. Now, in the switch, if you look here, you have created a channel on which A can talk, B can talk, C and D all can communicate with each other. That may be okay, but as my network grows, I want to ensure that only the required devices can communicate with each other. Not everyone should be able to talk to each other. A simple example could be, let's say you have an office floor like this big, and then you have asked people to sit without having any partition or anything. Now it may happen that, hey, here is an important task going on. This person is doing something important and he or she needs privacy or noise control, but here is a party going on and that can create problem for them. So what we do in these type of cases, we may have created, let's say, isolations, network isolation or partition. So this is a partition, or this is a training room, or this is cafeteria. So we have created isolation. So if something happens here, it is not going to affect people into other locations. That is what we are trying to achieve by switches also. What we mean by that? So let's say if you do not have isolation, then what is it going to happen? Let's say you have multiple switches connected. Why you would need multiple switches? Because one switch has a limit of how many ports it can have. So maybe you have 16 devices connected here, 16 here, 16 here, 16 here. And when one of the device here sends a packet which is called broadcast, it would be listened by everyone in the network, which can create a lot of noise. So what we do instead of this, we create something called VLAN or virtual LAN. So here you could see we have these switches, and these switches we have connected together, and through this we have created a virtual LAN. We have logically isolated the switches and said, hey, you 2 port, you belong to application VLAN, you 3 port, you belong to database VLAN, and you 3 port, you belong to maybe my web server VLAN. So physically they are connected into different switches, but still they are able to communicate as they are connected locally, and traffic in application VLAN will not be creating problem for databases or web server, because we are still isolating them by the routing devices. So we are ensuring that though they are physically distributed, but they still seen as one logical unit, and their traffic stays within that network and not goes to different network unless we want it to go. So that is referred as virtual LAN or VLAN for short. I hope this thing is clear. So you know a little bit on networking, you know a little bit on switching, and next chapter we will talk about routing, and then we'll continue and see how these components fit together into the cloud strategy of AWS.